गुड मॉर्निंग स्टूडेंट। प्रीवियस क्लास में हम लोगों ने डिस्कस किया था ग्रुप 17 और 17 में हम लोगों ने उसके एटॉमिक प्रॉपर्टी और फिजिकल प्रॉपर्टीज़ को डिस्कस किया था और उसमें कुछ चीज़ बचे थे, जैसे क्लोरीन, HCl, ये सब तो प्रिपरेशन, ऑक्सी एसिड्स है और ऑक्सी एसिड्स का स्ट्रक्चर या कुछ ऑक्साइड्स हैं। रिएक्शन जब ये ऑक्सीजन से करता है तो क्या बनाता है, तो ऑक्साइड्स बनाते हैं। जैसे फ्लोरीन का जो इम्पॉर्टेंट ऑक्साइड है वो O2F2 है और वो F2 है। तो यहाँ ये क्वेश्चन बनता है कि हम ऑक्साइड्स को, हम फ्लोरीन के कंपाउंड को विथ ऑक्सीजन हम लोग बोलते हैं उसको फ्लोराइड्स, जबकि अदर हेलोजन जब ऑक्सीजन से रिएक्शन करता है तो उसको हम ऑक्साइड्स बोलते हैं, उसको क्लोराइड और ब्रोमाइड नहीं बोलते हैं। इसका क्या कारण है ये जानेंगे हम लोग। दूसरी बात है कि इस कंपाउंड का कुछ यूज़ आता है, जैसे O2F2 का क्या यूज़ होता है, ये फ्लोरीनेटिंग रिएजेंट के रूप में यूज़ करता है, PuF6 बनाता है। ये किसी भी न्यूक्लियर रिएक्शन या रिएक्टर से जो फिज़न के बाद स्पेंट होते हैं उससे प्लूटोनियम को हटाने के लिए PuF6 में इसका यूज़ होता है। इसको हम लोग फ्लोरीनेटिंग एजेंट बोलते हैं। नाउ उसी तरह से क्लोरीन के ऑक्साइड्स हैं। तो हम लोग अभी जानेंगे ग्रुप 17 को कंटिन्यू करते हुए। ग्रुप 17 राइट, लेक्चर नंबर 11 होगा, तो इसमें हम लोग ऑक्साइड्स जानेंगे। मीन्स ग्रुप 17 एलिमेंट रिएक्ट विथ ऑक्सीजन फॉर्म ऑक्साइड्स। तो इम्पॉर्टेंट ऑक्साइड्स हमको जानना है। इम्पॉर्टेंट ऑक्साइड्स जैसे O2F2 है और OF2 है। अब हम इसी में क्वेश्चन था व्हाई इट इज कॉल्ड फ्लोराइड्स। इसको ऑक्साइड्स नहीं बोलते हैं, व्हाई कॉल्ड फ्लोराइड्स, कॉल्ड फ्लोराइड्स। इसको फ्लोराइड्स क्यों बोलते हैं, राइट, व्हाइल द अदर ऑक्साइड्स ऑफ हेलोजन आर कॉल्ड ऑक्साइड्स, राइट, while the compounds of halogen with oxygen, while the compounds of halogen with oxygen called oxides। क्लियर कर दें, एक्सेप्ट फ्लोरीन, फ्लोरीन को छोड़ करके। तो व्हाई इट इज कॉल्ड फ्लोराइड्स, ड्यू टू मोर इलेक्ट्रोनेगेटिव नेचर ऑफ फ्लोरीन। व्हाई इट इज कॉल्ड फ्लोराइड्स, दिस इज व्हाई इट इज कॉल्ड ड्यू टू मोर इलेक्ट्रोनेगेटिव नेचर ऑफ फ्लोरीन, नेचर ऑफ फ्लोरीन। And while other are called oxides because oxygen is more electronegative, that's why it is called oxides. While others, that is chlorine with chlorine, bromine, and this is with iodine, called oxides, regarded as oxides because less electronegative, because these are less electronegative than oxygen. This is so that's why this is called the oxides. Chlorine को दो important oxides हैं. Now this use of O2F2 is used as a fluorinating agent. Fluorinating agent. For what purposes? To remove the plutonium as PuF6 from the nuclear waste. To remove plutonium from nuclear spent as PuF6. This is the use of the fluorine oxide. Now the next oxide, if we take, this is the oxides of fluorine. This is all about the oxide. This is called the oxides of chlorine. Chlorine forms large number of oxides, which is Cl2, ClO2, like this. Oxides of chlorine, oxides of chlorine, Cl2O, ClO2, Cl2O6, Cl2O7, and we can easily calculate the oxidation number. Twice x 14, that is plus 7 oxidation state or oxidation number, plus 7 plus 6 plus 4, and here is this is plus 2x, that is 1. So these are the oxidation state of this. Now because this halogen has a d orbital, so it will form a large number of oxides. So this ClO2, this is very important and asked so many times. This is used as a bleaching agent. Bleaching agent. Bleaching agent. And for what purposes? That is bleaching agent for paper pulp, that we can write in simple way in paper industry and in textile industry. Bleaching agent for paper pulp, 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 and that is in paper industry and textile industries and textile industry. This is so industry. What is the use of this ClO2? Now bromine oxides are oxides of bromine. Oxides of bromine. This is Br2O, BrO2, BrO3, and these oxides are least stable. Now oxides of iodine. Oxides of iodine. This is I2O4, I2O5, I2O7. This will act as a strong oxidizing agent. The stability of oxides, stability order. This is stability order: iodide, iodine oxide, thereafter chlorine, and thereafter bromine. So bromine is least stable. Now iodine oxides are more stable. Now question arises, why oxides of iodine are more stable? This is one. So let us see. Chlorine form the numerous oxides, Cl2O, ClO2, Cl2O6, and Cl2O7. The oxidation state can be calculated. Similarly, bromine form this Br2O, BrO2, BrO3. It is least stable, that is stable at lower temperature, and then oxides of iodine, these are formed I2O4, I2O5, I2O7. This is I2O7. So this I2O4 is very common and it will act as a strong oxidizing agent. Now the stability order of the oxides. The stability order of oxide is iodide, and then chloride, then bromide. Why iodide oxides of iodine are more stable? Due to polarity, bond polarity. So simply, now the point is here, why the oxides of iodine are stable? Because as the size of atom increases, bond polarity increases, and bond polarity increases, stability of oxides increases. So iodine oxides are stable due to bond polarity, greater bond polarity, right? So IO bond is more polar, That's why these iodine oxides are more stable. So the order is iodine. Now the question why bromine? Chlorine is more stable because chlorine has a d orbital and it forms a vacant available d orbital and it forms a multiple bond with oxygen. That's why chlorine oxides are stable because chlorine has d orbital, so it forms bonds with it and hence it is stable. And the bromine is in between, that's why it is least stable because so it is stable only at the lower temperature. So this is all about the oxides of the that is halogens. So these are very important, right? Now simple reaction, halogen react with metal, reaction with metal kare. So this is all about oxides. Again we take the reaction of halogen with metal, and this is some M plus X2, that is Mx. This one twice Mx, twice Mx. So this form a ionic compound as well as this form a covalent compound. Suppose if we take that is oxidation state Sb, that is SnCl4, right? We take PbCl4, and this is SbF5, like this, SbF5, right? SbF5, then SnCl2, or we write here BiCl5, PbCl2, and if we take that is Na plus Cl2, as for example twice NaCl. So these compounds are ionic in nature because here this sodium is the most electropositive element. Chlorine have tendency to gain electron, so there is a ionic bond here and the compound is ionic. Now if here the oxidation state +4, +4, +5, and this is +5. So compounds in the higher oxidation state, compounds of halogen in the higher oxidation state are covalent in nature. Compounds of halogen in higher oxidation state covalent. That's why this compound is covalent, right? And the lower oxidation state, in lower oxidation state, these are ionic in nature. That is less covalent, so these are ionic in nature. And these compounds are stable due to the inert pair effect. So this is all about the that is oxides, and this is the reactions of halogen with the metal. It forms both the ionic compound, that is some compounds are covalent and some are also ionic. That also depends upon the oxidation state. Now the two preparation is in your syllabus. So what are these preparation? There's a chlorine and SCl. Group 17, preparation of chlorine. Preparation of chlorine, right? So there are three equations are given in your book, and you will consult the book for this equation. Suppose it is given in this way. This is first reaction, it is prepared MnO2 plus 4HCl. Instead of HCl, we take a mixture of NaCl plus H2SO4 plus MnO. This is another equation that is given in your book. So this is another equation. Now simply the third equation, this is KMnO4 and plus HCl. HCl. So you will complete. The question is asked complete and balance the equation. Question is complete and balance. Complete and balance the equation. Balance the equation. So you will see the book. For that you will see. This is simple. MnCl2 plus Cl2 plus H2. Here we put the 4HCl. Then we can. Now NaCl plus H2SO4 plus MnO2. Here 4H2SO4, 4NaCl. So NaHSO4 plus MnCl2 plus Cl2 plus H2. Like that. KMnO4, that is KCl, MnCl2 plus Cl2 plus H2. So this is you try your best, complete and balance the equation. These three preparations in your book. So you will go through the book. Consult the book. See the book. This is not any understanding problem, understanding difficulty, simply given in the book. You will see the book and write the equation. This will depend upon your practice. Now, complete and balanced type question is asked. Now, what is the chlorine? Chlorine, it is a heavier gas. Now, it is that is yellowish in color, and it is used in the preparations of so many compounds. Let me see. That is, some compounds are very useful. Some poisonous compounds may be prepared by that. So, question is asked, write the two compounds which are poisonous. So, let us see on. Now, the properties of this reaction. Now, it is also commercial method. Commercial. This is very by d.k.das process. d.k.das process. By oxidation of Cl2 in presence of catalyst CaCl2. This one. This is the d.k.das process. So you will remember. Write the name of that commercial process by which chlorine can be prepared. This is prepared by d.k.das process. So again you will see the book for that. Right? Here is the catalyst, then it can be. And another by electrolysis of brine solution. And another one is electrolysis of brine solution. Brine solution means sodium hydroxide, sodium chloride solution. Now the reaction is very important. Now the chemical reactions. See the chemical reactions of chlorine. So chemical reaction. Again the reaction is asked in the form of, that is balance, that is write complete and balance the equation. So for that you have to, so there are so many reactions are given. Suppose it reacts with let's say aluminum plus Cl2. So what will happen? Suppose Fe plus Cl2. It is given P4 plus Cl2. This is given, right? This one. Now S8 plus Cl2. This is given. So it will. This is you complete and balance it. Complete and balance. Right? So see the textbook. Right? Now this chlorine act as this chlorine also react with some chemical compound. Suppose it has affinity with hydrogen. Reaction showing affinity with hydrogen. Reaction showing affinity with hydrogen. Suppose करिए H2 है plus Cl2. This is very simple. This is H2S plus Cl2. So this is also very simple. HCl plus S. So these are the reaction showing this one. Right? Now again, so this is your task. You complete and do the practice. Now again, a reaction showing the affinity with hydrogen. Now reaction with another is reaction with NaOH. This is very important. This is NaOH, cold and dilute. Cold and dilute. This reaction, this is H2O. So this is very important reaction. And this is NaOH plus Cl2, concentrated and hot. These are two conditions. So here the reaction is NaCl, NaOCl and plus H2O. And here the reaction NaClO3 plus NaCl and plus H2 plus this is. So these reactions is very important, right? So you will balance the reaction. This is balance yourself. Balance yourself. Simply I give the idea what are reactions are the important, right? If you want to balance it, then you can easily balance the reaction. Suppose here it is twice है तो twice कर देंगे, इस तरह से balance करना है. और इसको हम लोग ले लेंगे 6 तो यहाँ 5 हो जाएगा, 5 और यहाँ 3 कर देंगे तो 5 3 हो गया, 5 1 6, हाइड्रोजन 6 हुआ, like this. So it will depends upon your practice, you balance it. Now the reaction with chlorine, this is very important. This reaction is also very important. Reaction with chlorine. Now this is NH3, reaction with ammonia. Sorry, reaction with ammonia. Now Cl2, if it is in excess, so here write HNO3. Again you balance all reactions, you balance. So this is NH4Cl plus N2. Now this reaction is also explained in the chapter of ammonia. Now this is NH3 and this Cl2, here Cl2 is in excess, then it will give NCl3 and plus HCl. Simply you balance it. All reaction, this is your homework, yourself. So this balance yourself, this balance yourself, right? Now the reaction with a dry select line. Reaction with dry select lime. Reaction with dry select lime. Dry select lime. Select lime is CaOH का whole 2 and this is Cl2. So it will give CaOCl whole 2 plus CaCl2 plus H2. This is called the bleaching powder. Bleaching powder. And the bleaching powder, simply in the class 10 we say that is CaOCl whole 2 is called the bleaching powder. But now in our advanced classes we say bleaching powder is a mixture of CaOCl whole 2. Why it is OCl2? This is calcium hypochlorite. Let us we see. Write calcium chloride, simply here OCl minus, its valency is 1. To satisfy the 2 valency, that's why OCl2. Then CaOH ka whole 2, then CaCl2, then H2O. The whole is called the bleaching powder. So you will see the reactions in the book and balance it, right? Now the important reaction is that is chlorine, this one, NH3 and this is one. All reactions are very simple, you can do it very well, right? Simply we take the uses of the chlorine, this is one. Now this chlorine, another reaction, acts as a oxidizing agent, you see. So these are reactions. already I had discussed halogens act as a oxidizing agent, and fluorine among the halogen is the strongest oxidizing agent, and that has already been discussed. What the reason? That is small size and high, that is enthalpy of hydration, right? Or in another way we can say that higher reduction potential value. Because all halogens are act as a reducing agent, so chlorine will also act as a oxidizing agent, right? So there are few reactions to show the oxidizing character, that when it is passed through ferrous sulfate solution, right? Then what will happen, right? So Fe acidified FeSO4 plus H2SO4 plus Cl2. Then it is passed through sodium sulfite plus Cl2 plus H2. Then it is ferrous sulfate H2SO4, and this is sodium sulfite, right? Then when it is passed through sulfur dioxide, iodine, then it is iodine, sulfur dioxide, SO2, H2O plus Cl2, iodine plus H2O plus Cl2. In all cases, these are the reaction in support of oxidizing agent. Reaction in support of oxidizing character, nature of what? This is chlorine. So this ferrous sulfate get oxidized to ferric sulfate plus HCl. This sodium sulfite get oxidized to, simply reaction can be written as Fe2SO4 whole 3 and plus HCl. You balance yourself. This is Na2SO4 and plus HCl. And this is H2SO4 plus HCl. And this is HiO3 plus HCl. So this is acts as the oxidizing agent. Is oxidizes iodine to HiO3. It oxidizes sulfur to sulfur. This is SO2 to H2SO4. Sodium sulfide to Na2SO4. FeSO4 to Fe2SO4. So this is your do yourself the balance. So this is your work. You do it. Now this use of chlorine. This is very important. Some question asked, write the two compounds which will act as a poisonous compound of chlorine. That is phosgene. First we poisonous compounds of uses of chlorine. It is used in the preparations of so many important compounds, right? Such as bleaching powder. This is it will act as oxidizing agent. It will use to prepare the some poisonous compound. वाला uses हो गया bleaching powder में. Bleaching powder used as a disinfectant. It's salt. Now in the COVID-19, generally inanimate object, we that is spray the solution, that is sodium hypochlorite NaOCl. This is the highly, that is disinfectant का काम करता है compound. तीसरा, used in the preparation of that is some poisonous compound. Some poisonous POISONOUS compound. There's such as phosgene. This is COCl2. And the mustard gas. This is tear gas. Mustard gas also tear gas. This is CCl3 and O2. This is. It is also in the preparation of mustard gas. mustard gas. This is Cl, CH2, CH2. This is S, this is S, CH2, CH2, and this is Cl. This is the formula of the mustard gas. So these are the uses of the, this is what? That is the chlorine. So this is called chloropicrine, and this is phosgene gas. These are the two compounds that are poisonous, and if it is asked to write the name of the poisonous compound, then you will remember these two, right? And other uses of this one, and how it will act as oxidizing agent. So the oxidizing agent. Now the another question is very important. Well, equation is given in the book. That's no problem. I just hint you that these reactions are very important. Now it is your duty to write the reactions in the balanced form. Now, see, question is, it will act as a oxidizing agent, and it will act as a bleaching agent also. So question is that bleaching by Cl2 is permanent, but by SO2, already discussed, is temporary. Why? This is the question. So see, and the ever properties is due to this Cl2 plus H2, that it will give HOCl, and this is HCl. We can write, see, in one time we can write HCl, and this is O. This one, again you see, this will give nascent oxygen. So this is the theoretical part. There is some reasoning question based on it. So the reasoning is very important. That needs explanation. So this is a oxidizing agent. Now colored plus O, that is colorless. This is called bleaching, and this colorless, when it happens, then it is permanent. It not be returned back to colored one. So why it is permanent? Because it is permanent. It's bleaching. ऐसा लिखें, its bleaching is permanent because done by oxidation. But if you will see SO2 plus H2, then it will equal to SO3 plus 2H. This is reduction. Colored plus H. This is colorless. So this is done by reduction. So temporary. So this is the question. Why bleaching, if done by chlorine, then it is a permanent. If bleaching is done by, that is the SO2, then it is said to be the that is temporary, and it is a permanent, because here the bleaching is done by oxidation process due to nascent oxygen. That's why it is permanent. If it is done by the reduction process, then it is said to be the temporary. Now time is over. So another compound that is HCl, that is discussed in next lecture, and the oxyacids. So HCl is simply the preparations. So I will discuss the oxyacids and little bit knowledge on HCl in next lecture. Thank you.